let's look at classifying chemical reactions. We have looked at several different types of chemical reactions: precipitation reactions, acid-base reactions. We've ignored gas evolution reactions, but we've looked at oxidation reduction reactions and combustion reactions, which are a type of redox. We are going to look at another way of categorizing these chemicals. These categories are known as synthesis, decomposition, single displacement, or double displacement. And you can tell by looking at a balanced equation which category an equation would fit into. Let's look at single displacement. Single displacement occurs whenever you have an element as a reactant and a different element as a product. It always follows that pattern. There will be only one element as a reactant and a different element as a product. And then the other reactant and the other product will be an ionic compound. Synthesis reactions occur when two or more compounds, or two or more reactants, I should say, two or more reactants form one chemical as the product. Decomposition is kind of the opposite. You have one reactant that breaks down to two or more substances. Now, double displacement is what we would place precipitation or acid-base reactions in. And what double displacement is when polyatomic ions switch. So when we have our hydroxide that switches with the phosphate and takes the H+, we get water. So phosphate in the reactant used to be with an acid, and now phosphate is with the potassium. Potassium used to be with hydroxide, and now it's with the phosphate. So single displacement, one element as a reactant, different element as a product. The other reactant, the other product, ionic compound. Synthesis, two substances form one chemical as a product. Decomposition, one reactant forms two or more products. And then double displacement is when ions switch. So here are examples of some synthesis reactions. When we have carbon monoxide and oxygen reacting to form carbon dioxide, two substances forming one. This would also be a redox reaction, but according to what we've looked at, this would also fall into synthesis. Here we have magnesium and oxygen forming magnesium oxide, two substances forming one. Again, this would be a redox reaction because we have an element or a metal and a nonmetal, or just looking at oxygen. And here we have mercury 2 iodide reacting with potassium iodide to form one compound. All of these are examples of synthesis reactions. Here are examples of decomposition reactions where we have one reactant. Now in this case, we only have one product as well, but because there's one reactant, it's going to fall in our decomposition category. And we notice above the arrow what causes the decomposition. Here we use electricity, here we use here we use heat, and here we use light. And what happens is these substances break down into something else. Now in this case, we're making two different forms of elemental oxygen. And the way that we know we're breaking it down is here we have two molecules, and over here we have three molecules. So we know that we're actually breaking it down. Water can be decomposed into the elements hydrogen and oxygen with a simple battery, and here it is being decomposed into the hydrogen and the oxygen. We can see the volume of the hydrogen is twice that of the oxygen because there are two hydrogens for each oxygen. Here are some other examples of double displacement. We see that ionic compounds or electrolytes are always as reactants, and then over here we have switching of our ions. So here we have calcium, and now it's with carbonate. Here we have barium, originally with hydroxide, now with nitrate. Here we have lithium, originally with carbonate, now with chloride. So these are all examples of double displacement. And by the way, double displacement are not redox reactions. So if you identify something as double displacement, it's not a redox. Here's an example of a single replacement. Here we have zinc metal, and when it reacts with copper chloride, it forms copper metal and zinc chloride. So we have an element as a reactant and a different element as a product. The other reactant is an ionic compound, the other product is an ionic compound, and this should be AQ here. So go ahead and pause the slide and see if you can identify the type of chemical reaction each one is, whether it's synthesis, decomposition, single displacement, or double displacement. And our first is a single displacement. We have one element as a reactant and a different element as a product. Here we have two substances forming one, so that's one compound, so that's a synthesis. Here we have double displacement because our ions are switching. Acid-base reactions are always going to be double displacement. And here we have decomposition. As we heat calcium carbonate, it breaks down to calcium oxide and carbon dioxide.